Hi everyone, sorry, done the recording on now. So we're going to do proportions. Again, we'll start simple. Proportions will probably be two parts. So we'll go over all the theory in this one, then we'll do some questions. So proportions are kind of like ratios, as in, you know, if one thing increases, does something else increase or does it decrease? So what would be the two kinds of proportions, Henry?
There's inverse, and then there is, I'm trying to think of the wording. It is disproportional. No.
What was that sound?
No, that was bad.
What was that sound?
Oh, that was my brother.
No. So which one is direct?
Direct is the left one.
So the linear one?
Yep.
You remember the symbol for the proportions?
No.
Almost like the infinity sign. So a direct proportion, what do you think an example of a direct proportion might be?
If it took far.
Or just an example of a scenario where we might have a direct.
If it took like 5 hours for one person to dig a hole, it would take 2.5 hours for 2 people to dig the hole.
Yeah, so it's increasing or decreasing at the same rate. So if we were to look at the speed of a car, if the speed of the car increases, it covers more distance in a fixed amount of time, right? So y, we would write it as y. X. What about an inverse proportion?
Well, the increase and decrease wouldn't be the same each time.
So if one quantity increases, the other decreases.
Yeah.
Yeah. So what could that be?
I guess. Let me think. Oh, well, you could have the digger hole scenario, but like the more workers you have, the quicker. Like each of them work, I guess, sometimes.
Yeah. What now? I'm having a breakdown. I can't think of examples. So what happens in week 10? Examples of inverse proportions. So more work, exactly like you said, more workers reduces the time to dig the hole. So this is an inverse. Just going to get rid of the chart. For 2 seconds. So we know the difference between a ratio and a proportion. So grade 9, grade 10, learn about ratio. Apologies for that. So in grade 9, 10, you learn about ratios. Grade 11, you start going through proportions. So let's look a little deeper into each one. So we'll grab this. So we'll start with inverse proportion, because it's probably the trickiest one. So you use the example there of the workers to dig the hole.
Yeah.
So if I was to make a table, and we had on here number of workers, and then we had over on the right number of days required. what would that look like?
Well, like for one person,
Yep, so one worker.
it could be like, say, 10 days.
Yep.
And then people, it could be like 8.
So 2 could be 8.
Yeah. And then like for 3, it could be like 7 maybe. And like then like 4 could be 3 or 4. We'll make it 4. And then
So four workers takes 4 days.
and yeah,
And what about 5?
Cool.
2.
Yeah.
So there is one rule here that we need to follow when we're writing our tables. The product of X and Y must be the same in each column. So I'm going to write out the first line. So if we started with, let's say we start with 16 workers and we go to 3. That's 48, isn't it?
Yeah.
So what if we went to 12 workers? Say we reduce the number of workers by 25% each term. So 12, 8.
Well, all of them. Would it be 20? Like, you couldn't make it? Could you make it 2 days? Or 4 days?
Yeah.
Oh,
You've got to equal
the numbers of workers are decreasing. I see.
Yeah. So yeah, I've done it just the opposite way.
Yeah. Yeah, and then for number of workers for 8, it'd be 5, which is 40. So no, you should have to make it 6.
Yep.
And then 4 would be 12. Need 12 days.
So yeah, as long as they all equal 48. Is there a sequence here? We've got an arithmetic or geometric sequence.
No. Oh no, it's an arithmetic. No. No, I'm not too sure what it is actually.
So yeah, there's no, it looks like a logarithmic. It looks like that classic J, but it could be anything.
Okay.
Yeah. So if we were to look at a graph of inverse proportions, we would have got the what? So here we got 0, x1, x2. We've got y, 1 over here, and y2. So if we back on, so our curve should look something like this, right? Roughly.
Yep.
So to write, I guess, a rule based on an inverse proportion graph, if we decrease the value from x2 to x1, sorry, increase from x1 to x2, we are decreasing from y2 to y1, aren't we?
Yeah.
So if we're increasing this way, we're decreasing this way.
Yep. And if you're increasing,
If we were increasing, we would go that way. wouldn't we?
Yep.
So that's the whole point of an inverse graph. What else? We did one in physics the other day. The pulley, the cart pulley. where you drop the weight off and you measure the friction and measure the acceleration? No, I can't remember that. All right. So direct proportion. So what's the difference between direct and inverse? Sorry.
Well, direct are going up by the same. Or
Yep.
the rate, or I guess the rate of change is the same.
Yeah. So what would we get a sequence here?
Oh yeah, you'd get a geometric.
Yeah, we get an arithmetic sequence.
Oh, arithmetic, sorry.
So for those who haven't started year 11 yet, arithmetic sequence goes up by the same number each time, or a linear equation. So for every time we get an x increase in x of 1, we'll get an increase in y, or a decrease if we decrease x. So if remember your y equals mx plus c, you should be fine for this. So let's look at, so I want you guys to draw x equals number of lollies you buy. And y equals money spent. So what would the graph look like? Take a minute or two to do that one.
Wait, we're doing inverse or direct?
Direct.
Direct.
Like if you're buying more lollies and you're spending less money, then you're probably stealing. So we'll look at the graphs, and then there's this. Have they taught you the constant of proportionality yet, Henry?
I can't. That doesn't ring a bell.
That's okay. Because as usual, we can solve these mathematically.
I just had it going like through the x value and like
Yeah.
changing one each time. So like one lolly cost $1, 2 lollies cost $2, and so on.
So yeah, it should look something like that. So that is a direct proportion. I'm going to go back a little bit. And we're going to look at this constant of proportionality. So if we were looking at because we'll look at this constant of proportionality and then we'll use it to solve a couple of these problems. So for direct, the formula is y equals kx. For variable inverse, it is y equals k of x. So same thing, y value is the y value, x value is the x value, k is the constant of proportionality. Or if we were thinking in terms of sequences, so let's say we bought 10 lollies. And it costs $50.
you'd get 50. So you'd get y equals kx, and then y equals 50. So you get 50 equals 10x. So then you just x equals 50 divided by 10, which equals 5. So each lolly is $5.
Yep, hang on. Oh, sorry. So we could divide 50 and 10. I think the way that you just did it, we'll get the same answer. They give us 5, right? So with each increase, we're going to see an increase of 5. So, well, we could use another example. So if 2 apples, sorry. If 2 apples equal $20, sorry. If 2 apples equal $20, we can assume that 1 apple equals $10, right? So the constant of proportionality for that apple would be 2. So let's try another one. So if we had y equals 24 and x equals 3, and we had y, remember I was talking about that proportionality, so y is proportional to x. How would we figure out the constant of proportionality? Will we just take 24 and divide it by 3?
Yeah.
So k equals 8.
Yeah.
So the constant of proportionality is the x value divided by the y value. Sorry, x divided by y.
No, isn't it y divided by x?
Yes, sorry, got it around the wrong way. 24 divided by 8. So here's one that I'm going to give you a minute or two to solve. So if 4 workers take 3 hours to finish, if 2 more workers are hired, how long will it take to complete the work with the additional 2 This is where you're going to need to figure out which one's y1, which one's y2, which is x1, which is x2, and figure out which one you're solving for. So I'm going to give everyone a minute or two to have a think about this one. So I'm actually going to leave this one until the answer to this one until next week. So we're going to go ahead a little bit. I've got a little bit more theory to cover. But have a think about it. You're solving for x1. So the number of hours being on the x-axis, we know x2, but we want to know the proportional drop as we increase by 2. There you go with that one, Henry. We'll come back to it next week. I just want you guys to have a think about it.
Yeah, I think I got the answer.
Tell me if you got. Tell me what the answer is.
I got 1.5 hours.
Sorry.
I got 1.5 hours.
Oh, close. 2. It's 2 hours. We'll go through the proof for it next week once everyone's had a go at it. Okay, we'll do a little bit more work on identifying because to enable, in order to answer that question, we need to be able to identify it with proportionality. So number of days, X, so let's call it 1, 3, 5, 6. And then we've got, let's call it number of articles written. So how would we figure out the proportionality from that graph? And is it a direct or inverse proportion? And remember that our constant or K equals Y over X.
It's a direct proportion.
So it's going to be direct. And what's the constant?
For every day, there's 3 articles written.
So K equals 3.
Yep.
Perfect. And we get a nice straight line. For every increase in X, we get an increase in 3 on Y.
Yep.
Ooh, I think I finished 2 minutes early. I think I finished early. Thought I had it planned out perfectly. Come up with a question now. What about percent proportion?
We've done a little bit, but not too much.
So what's 30 is what percentage of 60? Obviously, this is percent proportion. You won't do a huge amount of percent proportion because it's pretty simple.
Oh, we haven't done this, but we'd like to learn it.
30 is what percentage of 60?
Isn't it just a half?
Yeah. So how would you just do 30 divided by 60 times 100%? If the formula is over of. So 30 is what percentage of 60? That's the easy way to remember it. Is over of times by 100%. What else? What else is there with this? I think that's everything for the proportion stuff I want to start with. I'll probably do another recording this week, maybe. I'll let you guys know. There'll probably be a few extras in the holidays as well. The second week of the holidays. And we'll finish off that proportion question and do a bunch more questions. But I will see you guys. What is it? Not next week, but the second week of the holidays. We'll do a few extra sessions to make up for because they're only going for like half an hour, 40 minutes rather than the full hour.
Okay, thank you, Liam.
See you guys.